The section's on 3.3, logarithmic functions and their graphs. So we're going to change from logarithmic to exponential first in the format, and then we're going to go into the exponential into logarithmic, and also natural logs to exponents and exponents to natural log as well. So there's two main or key things that we're going to do, but we're going to change the format as well. So one of the things we're going to go over is some of the restrictions. So it says that x is greater than 0 and b is greater than 0, but this b cannot equal to 1, then this follows true. So this right here, the log, and then this is called base right there. So it's a little subscript down there. That's a base right there. And then there's an x that's next to it. Okay? So that's log base b, x. If and only if will turn into this format right here. So this b right there is also now the base for the exponent, right? The exponent is the power that we have up here is equal to x. Okay? So what we're going to do is we're going to take this log base b. This is like a package deal. All of it's going to come together, and we're going to bring it to the other side of the equal sign. Now when you take all of this to the other side of the equal sign, since you're changing it to logarithmic to exponential, exponential does not have the word log. So the word log disappears right there. Okay? So now this base b becomes this b right here instead. So then the y right here, which was currently a large y, will be pushed up as an exponent, which is this part right there, and is equal to, then the x, which is by itself, is equal to x right there. Okay? Now going the other direction, we're going to take this right here. Right now, this is in exponential form, and we're going to change it to logarithmic. So when we change the exponential form to logarithmic, this right here is base right there. So this base, when we bring it to the other side of the equal sign, because you're in logarithmic form, now the word log has to appear. So this log right there and that base right there number becomes the base of that log. The x right there gets pushed aside, and then the y, which was currently an exponent, will drop down and becomes a large y, which is this part right there. Okay, so that's the movement from changing one form to the other form. Now let's also go through some properties. So there are 4 properties for log. One of the property is then if log base b of 1 is equal to 0. So if I change this right here, bring it to the other side of the equal sign, remember that base right there becomes an exponential base, and then the 0 gets pushed up and becomes an exponent right there, and then the 1 is equal to 1 right there. So b to the any power of 0, or anything to the 0 power, right, is equal to 1. So that's a true statement right there. Okay? Now let's do log base b of b is equal to 1. So if I take all of this right here, log base b, and I bring it to the other side of the equal sign, that b becomes this right here. The 1 gets pushed up as an exponent, equals, and then this b, which is by itself, becomes this b right there. Okay? Now let's take this, log base b, b to the y power is equal to y. So again, I'm going to take all of this right here, I'm going to bring this to the other side. The word log disappeared because now we're not in logarithmic form, we're in exponential form. So this b right there becomes this b right there. The y gets pushed up as an exponent, and then equals, and then this comes by itself, it's like the loner, right? So that's this part right there. Okay? So which is also a true statement that we're saying b to the y power is equal to b to the y power, because anything by definition of equal means that this is equal to the other side. So now on this part right here, we're going to take the log. So probably should have switched it actually. Should have been the log format on that side. But let me just go from here then. So log base b of x is equal to log base b of x. This is equal to each other. So if that's equal to each other, what happens is this right here, if I bring it to the other side of the equal sign, right, this log disappears because we're going to change it from logarithmic to exponential. So this b comes as a big B, which is this right here, the base right there. And then all of this right there gets pushed up, which becomes this right there, equals, and then this is the x right there. Okay, so that's the property. So now let's try some examples. So example 1 says to change the logarithmic form to exponential form. So we're going to take this right here and we're going to change it. So taking then the log base 2 right there, and we're going to bring it to the other side of the equal sign. So now we're leaving the 8 alone right there, because that's this part right there. We're leaving the 8 alone. and I bring the 2, that becomes the base, right? And then 3 gets pushed up as an exponent. So now this is now in exponential form. Now if you check it, 2 to the 3rd power is like 2 times 2 times 2, which equals to 8, right? So that's a true statement. That's how you're going to check your work as well. Okay? So that's going from logarithmic to exponential. Now let's try the next one. So the next one is log base 3. We're going to take all of this right here, log base 3, bring it to the other side of the equal sign. So that square root of 3 is left alone right there, is equal to, the word log disappears, and we have just the 3 that becomes the new base right there for exponential. The half gets pushed up, and then this becomes right here. So remember, this half is the same thing as the square root right there, right? So this is equal to each other right there, okay? So now let's try another example. We're going the other direction. So we're changing now from exponential to logarithmic form. So now we're going to take this right here, the 3, which is the base, and we're going to change it over here on the other side. The word log is now going to appear because now we're going to go into logarithmic form. So I'm going to have is log base 3, right? Because this base right here was this base right here. 27, so the 27 just gets pushed over to the side, is equal to, now this x drops down from becoming an exponent and becomes a big X right there. Okay, so this is now the logarithmic form. And again, I can always check my work by bringing this log base 3 over to the other side of the equal sign. If I bring it over to the other side of the equal sign, this 3 becomes a large 3, that base right there. X gets pushed up, and then 27 is by itself. Okay, now let's do the same thing with this one. So we're going to take this, we're going to change the 6 right there, we're going to bring it over to the other side right there. So if I bring it over, the word log appears. This is the base right there, that's 6. 11 gets pushed over to the side, equals, and then the rest that was in exponent form is going to drop down, and it's going to be the big numbers right there, or letters. And so this right here is equal to the other, which makes sense, right? Okay, so that's from logarithmic to exponential and exponential to logarithmic. Now, let's go to another format. The other format is now changing from natural logs to exponential. Now, natural log is the same thing as ln. So we've worked with ln before, and exponential is the e is what I'm talking about, okay? So when ln of x, if and only if e to the x is, or I'm sorry, e to the y is equal to x. So now, same thing with the log format that we just did, but a little different because ln never has a base actually. So ln has a number that's next to it. So we're going to take this ln right there and we're going to bring it to the other side of the equal sign. Now when ln moves over to the other side of the equal sign, it changes its identity to an e instead. And then the y gets pushed up just like the other one that we did with the log. It's pushed up and equals to x. Now x is that same x as this right here. Okay? Now the other way is going from e to ln. So e, if I bring it over to the other side of the equal sign, turns into ln, which is this format right there. X gets pushed over, just like how we did with the log format. And then the y drops down and becomes this y right there. Okay? So now let's go over some properties. So for the properties, so one of the properties says that ln of 1 is equal to 0. So if I take this ln right here and I bring it to the other side of the equal sign, we said the identity changes to an e. E to the 0 gets pushed up right there, equals 1. Anything to the 0 power is equal to 1, so that's a true statement. Same thing with this one. If I take the ln right there, bring it over to the other side of the equal sign, turns into e, right, because ln changes identity to an e. E to the 1 is equal to e. Now when you have, like, this is like an x. If I have an x, we know the exponent up here is equal to 1. So we don't necessarily need to write a 1 up here, but if you need to, that's fine. Okay? So now let's change this format right here, the ln. So this right here, if I bring it over to the other side of the equal sign, it turns into e right there. So then this gets pushed up as a y, and then the ey, which is on that side right there. Okay? Now let's change format right here. So e, if I bring it to the other side of the equal sign, e turns into ln. So this is the ln right there. And then the x right there is this x right there. This drops down, and so it becomes this right here. Okay? So those are some properties, meaning that it could be either this format right here or it could be this format right there. All right? So now let's try some examples. So the first example then is taking the ln of e square root of x, or I'm sorry, square root of e, equals x, and we're changing the format. So we're changing from ln to e. So again, it's like the log. If I change format, the word ln disappears. So I'm taking just the ln right there, bring it to the other side of the equal sign. The square root of e is still there, is equal to, now ln turns into e, so it becomes e to the x power right there. Okay? Now, I can change this right here square roots because then the power of that becomes half. And if you remember in Algebra 2, this is the inside and this is the outside right there, right? So if this is in over out, this is in right there, and this is out right there. Because square root, there's a little imaginary 2. Normally we don't put 2 for the square root, but from that power on, like the cube root and the fourth root, we do put an exponent right there, okay? So equals e to the x, and now we're going to actually solve for x. So since the base numbers are the same, and we're saying that it's equal, then x has to equal to a half right there. So in this case, x is equal to 1/2. Okay? Now let's try the next format. The next format is then taking e and we're putting it into ln format. So if I bring the e over to the side, this gets dropped down, right? So ln 4 gets dropped down is equal to, and then e turns its identity into an ln, and this is 4 right there, so 4. So which, it was one of the properties that we said right here, right? So it's the same thing as this property right there. Ln of 4 is equal to ln of 4, and ln of x is equal to ln of x, same format right there. Okay, so those are the things that we're going to work on for the classwork now.